So one way we can use an infinite geometric series is to take a repeating decimal, and then we can change it into its equivalent fraction. All repeating decimals can be changed into an equivalent fraction. And there's actually more than one way to do this, but we're going to show you this way because we're in this chapter. Okay, so think of the number 0.33333 and it's repeating. Well, then what we have is we have 0.3 plus 0.03 plus 0.003 plus ... and that's just going on forever and ever. Well, it is geometric. If you take the first two terms and you take 0.03 and divide it by 0.3, you're going to get 0.1. So you can do that on a calculator. And if you take the next two terms, you're going to have 0.003 divided by 0.03, and that's also going to be 0.1. I find it easier to look at it in terms of fractions. It's like 3/10 plus 3/100 plus 3/1000 plus on we go. And so you can see that the ratio is 1/10. Okay, you're multiplying each term by 1/10. Okay, but you can use the decimals. Decimals or fractions, either way. Okay, so now we want to find the actual fraction. So what we need is that sum of an infinite series, infinite geometric series problem. So it's a sub 1 over 1 minus r. Well, my a sub 1 in here is 0.3. I'm going to go with the decimals. Usually I do fractions, but it's okay. And then I'm going to have 1 minus 0.1 in the denominator. By the way, the ratio is less than 1. It's between, I forgot to put that there, but it was between -1 and 1. Okay, so this is going to be 0.3 over 0.9 if you do that subtraction. And so you can divide that out. You could multiply by 10. I'm whispering. Like, this is my cheaty way of doing it. Multiply the top and bottom by 10, so you get 3 over 9, and then reduce the fraction. So it's 1/3, which you probably knew that one, but you could do this same process for a repeating decimal that you didn't know. And I would take the time to do that, but the next video is probably going to be a little bit longer, so I won't do another example for you.